We'll call this lesson 19, day 3. I did call the last video day 2. We'll call this day 3, geotrig. And what we're going to do is we're going to simplify this problem. At first glance, you're probably like, there's nothing in common on the top or the bottom that I can factor out of the top, factor out of the bottom, and then just cancel out, right? But what we need to realize is that there's something going on with those exponents on top. X to the 2a minus y to the 2b. Couldn't I use power over power and kind of rearrange those a little bit? Couldn't I then say that this is really just x to the a squared minus y to the b squared all over x to the a plus y to the b? Well, that's kind of interesting. Does the top remind you of anything?
That's like the slope.
Remind you of this? I think we did that yesterday.
Yeah, we did.
The difference of
Two squares.
squares. The result of the difference of squares is? Again?
Oh, plus and minus.
Plus and minus. A plus b, a minus b. What's being squared in the first parentheses up top? X to the a. What's being squared in the second set of parentheses? Y to the b. That's your a and your b. Now granted, guys, you got to know that this a and b here is not the same as that a and b in the problem. The suppositions. So this becomes a to x to the a plus y to the b times
X to A minus Y to B. Gotcha.
all over
X A plus Y B.
y, and then you can do what? Simplify by cancellation, and your answer is
Wow.
That was nice.
Crazy.
not too bad, right? But you had to recognize your exponent rules. You needed to break it apart a little bit, unpackage it just a little bit, right? Just enough to visualize, realize that you have a formula for things. Guys, this is the same exact thing. This is the reason why we did that problem, is because now we're going to use the sum and difference of cubes. Before, there was only the difference of squares. There is no sum of squares, guys. That doesn't work out. But there is a sum and difference of cubes. It's if you may find out that you have a binomial made up of perfect cubes. It's a perfect cube minus a perfect cube, or a perfect cube plus a perfect cube. If you're looking at these two formulas, there's not much difference. I personally do not remember them any differently. I just write it down once, and then I make one slight adjustment. So let's take a look. What's this act, guys? That the second one doesn't even exist. How am I supposed to know that if it's not the a cubed plus b cubed, what if it was a cubed minus b cubed? Well, guess what? There's a slight difference. That slight difference is the fact that instead of it being plus, it's minus there. Right? Well, here's the cool thing. It factors to a minus b, and then changes to a squared plus ab plus b squared. So all you're doing is changing a couple signs. What's that? Because anytime you square a number, it's always positive. So that's why the last one will stay positive. So I'm going to bring this back. Notice that's exactly what we just erased. Okay? So I only remember one form of this, that it's a cubed plus b cubed is equal to a plus b times the quantity a squared minus ab plus b squared. You guys are going to need to know this. That's the sum and difference of cubes. I'm going to treat it the exact same way. Notice steps 1, 2, 3, 4. It's exactly what I talked about and had done yesterday with the difference of squares. I set up my parentheses. This time, it's something cubed plus something cubed, or something cubed minus something cubed, right? Just like the last problem. I said something squared minus something squared. The whole idea is to figure out that position. Because remember, this is an A inside, and this one is a B. It's the position in the formula. So you figure out what is being cubed in each part. AKA, take the cube root instead of the square root like you did last time. Those are your A and B, and then you fill it in the appropriate formula. Let me find out what the next example is real quick. Start off with something even easier. Do this for me. Plus, let's do 8. After this, please. X cubed plus 8. So we're adding more things to our repertoire of being able to factor. You guys actually should have done this probably last year. Been introduced to something like this. So now you have to factor x cubed plus 8. What do? I break down and put parentheses. Something cubed plus something cubed. And then I just ask myself, what's being cubed to get x cubed? X. What's being cubed to get 8? 2. You now know A and you know B. Plug it into the formula right above. Which means it should be x plus 2 times x squared minus 2x plus 4. 2 squared or 4. We're going to start off a little easier and then work our way into a little more in-depth problems. Factor x cubed y cubed minus p cubed. Notice everything is cubed. So therefore, you are looking at this saying, hey, it's a binomial, 2 terms. It's got a subtraction sign. Is this the difference of squares? Well, no, because the difference of squares would have to have perfect squares. P cubed at the end there is definitely not a perfect square. So that means by default we should check to see if this is a difference of cubes. We do that by setting up parentheses. Something cubed minus something cubed. What's being cubed to get x cubed, y cubed? xy. Why is it an xy? Yes, because the cubed would be distributed, right? It's a power of a product. So x cubed, xy, the quantity xy cubed is x cubed, y cubed. And the next parentheses would be p. You now know your A and you know your B. So when I factor it, it equals x minus p, xy minus p. That's the easy one. xy squared. Change the sign. x, y, p. Plus p squared. And to probably make this just a little bit better, I'm going to clean that up, right? So xy minus p. Then it becomes what? X squared, y squared. If you want, you put things in alphabetical order. So that would be what? P first, and then xy plus p squared. Any questions? That's not too bad. We'll kick it up even more. Just a little bit, not too much. Factor this one, I'll give you guys a couple seconds. What's being cubed to get 8m cubed y6? 2m y squared. Because remember, I'm going to distribute that 3, so it'll be 2 to the third, m to the third, and y to the 2 times 3, which is 6. And x by itself. Plus x.
And then it would be 2my
Squared.
squared?
Squared?
Oh, okay.
Minus?
X. Yeah.
Plus x squared. And again, my last step would be clean that up. I'll let you guys do that so we can get to the next problem and potentially have some time to work in class on our work. Any questions? No questions?
No.
Okay. Turning the page. Not really getting too hard on these ones. You guys are getting lucky. These ones aren't too bad. I think the stuff from yesterday was probably harder than this for sure. So if you took the cube root of 64, you get 4 p to the x to the m to the 2. Now, is this any different than what we've been doing now? Over and over and over. So I'm not going to finish this problem either. I think we're pretty comfortable, hopefully, with this. You guys can compare your answers to each other. Homework for today, lesson 19 is page 143, 10 through 14, and 20 and 21. Have a fantastic day.